Hey guys, welcome back to another Tenfold Live. My name is Philippa and I'm here to bring you back to one of our really exciting math series education episodes, proudly brought to you by Liberty. Over the next 3 terms, we're going to be bringing you a lot of maths content and eventually some science content, guys, to get you up and running for your matric and ready for your exams. So make sure you tune in every Monday to Thursday from 5 to 6 p.m. We have a great selection of videos coming your way, guys. We're prepping these live shows with you in mind. We're gaining your questions. We're going through them. We're loving all the feedback you're sending us, guys. So carry on hitting us up on our Facebook and our WhatsApp. Send through those videos. We love hearing from you, guys. If you need a little bit of a bump with your education and you feel like the show isn't giving you enough, go and download our app, guys. It's called Tenfold Education. It's available on both Android and Apple iStores. It's also brought to you by Liberty. It's really great, guys. We put together some fantastic videos. It's got career videos, it's got concept videos, it's got all of our examination videos to help you revise all of your maths content. We also have some science stuff on there, guys, so make sure you download that app because we've assembled some really great content for you. Anyway, let's just jump right into this episode. We're continuing with this week's topic. We're doing differential calculus. We're loving all the stuff you're sending through to us, guys. It's really great mind-melding stuff. So we're really loving helping you out. For now, we're going to jump into an intro video, and then I'll be back to take the next question. So stay tuned.
Calculus is a powerful and magical mathematical tool that allows us to make predictions of future outcomes and reconstruct the past. In order to be successful at differential calculus, you will need to understand the concepts of limits, differentiation by first principles, differentiation using rules, equations of tangents to graphs, cubic functions, optimization, and rates of change. In preparation for your exams, make sure to watch all of the Financial Maths Back to Basics and demonstration of concept videos, and attempt all of the assessment questions at the end of the lesson. Once you've mastered those skills, the enrichment and career videos will take you beyond the classroom. Differential calculus is 35 plus minus 3 marks in the final exam, which is about 24% of Maths Paper 1.
Hey guys, and welcome back. Hopefully that video has helped you gauge some of the stuff we're going to be using in this episode. We've got some great learner questions. I'm going to jump straight into the first one, sent to us by Malaika, so let's see what she wants help with.
Hi Tenfold, my name is Malaika from North Riding Secondary. Please help me with this question.
Okay, I'm going to be honest with you guys. When I first looked at this question, I didn't love it. I don't love rates of reaction and rates of things being filled and stuff. For me, that's like really physics orientated, and I don't love physics. But I took a look at this from a calculus perspective, and I kind of made sense of this. So let's try and work through this question together. I'm going to read it out to you. It says, a drink dispenser is able to fill up a 340 ml cup at a rate of X mils per second. Okay, so the volume is important, and that rate is important. It also says, if the rate increases to X plus 2 mils per second, the time taken to fill up the cup will be reduced by 3 seconds. Determine the original time taken to fill the cup. Okay, so let's write out the variables that we've been given. We know that the volume of the cup is 340 mils. We also know that we've been given not only one rate, but 2 rates that it takes to fill up this cup. So we know that rate number 1 is equal to just X mils per second. And we know that rate 2 is equal to X plus 2 mils per second. It also says to us, check me out, me and my technology. Okay, it also says the time taken to fill up the cup, if it is increased, the rate is increased to X plus 2 mils per second, it will be reduced by 3 seconds. Okay, so that's important. Now guys, when I looked at this question, I kind of wanted to relate it to something that you guys are already familiar with. So you really all should recognize this triangle here, the DST triangle. We know that that is the distance that we work out in kilometers. That is the time taken, not usually in seconds though, time taken to travel those kilometers, which is hours, and this is the speed, which is kilometers per hour. Okay, so if I look at this diagram immediately, guys, I see that this is a rate. This is the rate at which we travel kilometers per hour. Okay, so if I want to try and relate this triangle to the question we're working with, we have the volume of the cup up here, which is given to us as 340 mils. We have the time it takes to fill up the cup, which was given to us as, first there's one time, and then at the second rate, it's the time minus 3 seconds, because it said it's going to take 3 seconds less to fill up the cup, okay? And then the last variable in this triangle is the rate. So firstly, we're given one rate, which is at the normal rate, which is x mils per second. And then the second rate is x plus 2 mils per second, okay? And we know that these two relate to each other, okay? So guys, when we're trying to relate everything in this triangle, we know that if we want to go that way, we multiply. And if we want to go this way, we divide, okay? So if I try and write out equations from this triangle, guys, we can say that the first rate, x, is equal to the volume, 340 mils, divided by the time it took to fill the cup. And then I'm just going to say is t. If we look at the second rate, we can say it's equal to the volume divided by its time, which is that reduction by 3 seconds. Okay. Now, we're trying to find this t here. So if I make x the subject of these formulae, I can solve them simultaneously. So this one, it's already the subject. If I say with this one, it's x equals 340 divided by t minus 3 minus 2. Okay, so now we have two equations where x is the subject. So the first one was 340 minus t, and it was equal to x, which is also equal to this 340 over t minus 3 minus 2. Now we just need to solve for t. So we multiply out the denominators. We get 340 multiplied by t minus 2 multiplied by both denominators, guys. Don't forget that. If we further multiply these out, we get 3 times 340 is 1020. It's equal to 340t minus 2t squared plus 6t. Okay, so now I want to try and get it into standard quadratic form. So I say 2t squared minus 6t. These two will subtract from each other. Minus 1020 is equal to 0. Okay, I don't really want to work with the factors of 1020, so I'm going to use the quadratic formula, which says minus b plus or minus b squared, which is 36, minus 4 multiplied by ac. Okay, and that's all square rooted over 2a, which is 4. So now I need to get out my calculator. And I say 6 plus the root of 36 minus 4 multiplied by 2 minus 1020 all over 4. And I get an answer of 24, comma, I think it was 13. Let me just double check. Yeah. And that was seconds, because our rate was given to us in seconds. If I substituted this minus into our quadratic formula, guys, I would get a negative answer, and time is never negative. Okay, so hopefully, guys, this has helped you try and manipulate what you're given in a calculus question and try and relate it to things that you already understand, guys. If you understand that DST triangle, which every math student does by now, try and relate it. If you have a rate question, try and understand what that rate means and manipulate your variables. So hopefully this has been a great first question for you guys. I really love doing it. I love being challenged in my maths. For now, we're going to jump into an ad break, and then Siyabonga is going to be back with another question. So make sure you watch the rest of the show, guys.